Okay, so we're going to look at solving differential equations. The only form of differential equation you'll get at A-level further maths is something called a separable differential equation, which are nice and easy to solve. So an example, we're going to do two examples, and then we're going to give the general idea. So a differential equation just means we're given some equation involving derivatives, basically. So this is an example. So dy by dx is equal to x over y. And we want to find the original function y as a function of x, which satisfies this. We don't necessarily have to write it in that form, but we want to find some relationship between x and y, not involving dy by dx. Okay, so if we had dy by dx was equal to some function of x, that's technically a differential equation. So, but all we'd have to do there is integrate both sides, and then the integral of dy dx is just y, and then the other side would integrate to whatever, some other function of x. And then we'd have y is equal to a function of x as we desire. Here, because the right hand side is a function of x and y, we can't just directly integrate. But what we notice is that this function x and function of y are what we called separable, meaning if we multiply both sides of the equation by y, or it doesn't have to be y, but in this case it's y, the x and y are now on different sides of the equation, and then what we do is we bring up this dx, so now we have y dy equals x dx. Okay, so you can think of it as multiplying that, but not, that's not really what's going on. Like I say, again, it's all these things are sort of chain rules. And then we'll take integrals on both sides, and now we just integrate both sides, okay, because this is a function of y, so we can integrate with respect to y. This is a function of x, so we can integrate with respect to x. We get y squared over 2 is equal to x squared over 2. We have to add the constant of integration to one side. We could add it to both, but then subtracting one of the constants from the other side, it would just give us a new constant, if that makes sense. So y, we just write one constant of integration on the end, and we can find that accordingly given boundary conditions. So plus c, multiplying that by 2 gives us y squared equals x squared, and again 2 times c is just another constant, so we'll just call that k. We don't do it 2c and make the expression more complicated than it needs to be. So here, that's our form. If we want to find y explicitly in terms of x, we can take square roots, but we'll just leave it like that for now. That's a relationship between x and y. Okay, so example 2 is one exactly of the other form I was talking about, which is still a separable differential equation. It's already separated. It's just a function of x. But so you can say, oh yeah, integrate both sides with respect to x, but you can also write this as the integral as 1 dy, integral as x cubed dx, and that gives y is equal to x to the 4 over 4 plus c. Okay, so hopefully you can see the idea with these separable differential equations. Some of them might be a little bit trickier, and yeah, sorry, I'm saying this is the only form you'll get. I think I said at further maths, but I mean A-level maths. At further maths, you get some slightly different forms and some second order equations too. In general, the separable differential equations take the form dy by dx is equal to f of x g of y, and the solution is given by integrating 1 over g of y and setting that equal to f of x, the integral of f of x with respect to x. Of course, that assumes that g of y is not a vanishing function, it's not 0, and that these functions can indeed be integrated. Okay, so that's it for this video. It's not a particularly complicated topic. Yeah, just you have to get used to this idea of a differential equation, but it kind of makes sense in terms of maths and applying it to the real world. If you think a differential equation measures the rate of change of some variable, it makes sense that a variable is going to be related to its rate of change somehow. So these equations do arise, and there's one way we can solve them if they take this simple form. So thank you very much for watching this video, and I hope to see you in the next